Hey guys, hello everyone and welcome to the channel. So today I posted a video regarding TIFR exam and I told everything about it, like how to what type of questions to expect, where to study, what are the topics which you should leave, what are the topics which you should study, what is usual cutoff of TIFR exam. So in that video, most of you requested me to solve previous year's questions. Now it's difficult to solve each and every question, so I thought to take TIFR 2020 exam question paper. Because there are 40 questions, I could not solve all of them. I just thought to tell you, or just to solve 10 of the questions in front of you. Some of them are easy, some of them are tricky. And in case if you have not watched the previous video regarding the TIFR exam, regarding where I have discussed um, about the cutoff and the other things, so the link will be there in the I button. You can click on the I button and watch that video. I'll be taking questions from TIFR 2020 exam, and 10 questions I have taken. Physical chemistry questions mostly. I would request you to download TIFR 2020 paper and check the questions out. Okay, the answers are already marked, but you should know the reason that how to come up with the answers. Okay, so without wasting any time, let's continue with our video. Alright, so we'll start from this question. This was a question from your group theory. It says that an isolated water molecule has C2V symmetry, okay, C2V point group. However, water cluster can have symmetries other than C2V, okay, it's given, this much information is already given to you. Now it says what are the symmetries of the given 3 water clusters. So these are the water clusters which are given to you. You have to tell what are the other symmetries which you have. So the first one is pretty simple. You can see that you have a C2 axis passing through the molecule like this, and you have vertical planes, one plane going through like this, and the other plane is the screen of your mobile or laptop, wherever you are watching. So the molecular plane itself. So there are two planes. So C2V is the point group for this molecule. Okay, so this will have C2V point group. Talking about this, in this particular molecule you have a C2 axis just like you were having in the previous one. Apart from that, you have one more C2 axis which passes through the molecule like this, and one more C2 axis which goes inside the screen through this point. So you have 3 C2 axes. If you consider any one of them as the principal axis, the other two becomes perpendicular to that. And you know, wherever you have Cn plus n number of C2 axes, in that case it becomes equals to Dn point group. Now here you have C2 plus 2 C2 more, so this will become D2. Now do you have a horizontal plane? For that you have to see that which is the principal axis. So let's assume that this axis, this particular axis is the principal axis. Now we have a plane which is like this, right? And this plane is bisecting the molecule into 2 equal half, and this plane is perpendicular to the principal axis, and that's why the point group becomes D2H. So the first one is C2V, second one is D2H. The third one is not having any axis. You can see that both the molecules are away from each other. You cannot put any axis on any one of them. So there is no axis present, but there is a plane present. The screen itself is a plane which bisects the molecule into 2 equal half. So you only have a sigma symmetry operation over here apart from identity. So this is basically the point group CS. So this is having CS, and that's why option number B is correct. Okay, so this was easy one. But yeah, you should have a good knowledge of applying axis and symmetries to answer this question. Okay, the next question here, it says that an ideal gas obeys the gas law PV is equals to nRT. However, real gas deviate from this, and their behavior can be described in this equation, that is PV divided by nRT is equals to 1 plus BP plus dash 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 and so on. Okay, so it says where BP is first virial coefficient in the expansion, do you expect BP to be temperature dependent? If so, what would you expect to be the sign of BP to be at low temperature? So here is where you have to apply a lot of knowledge regarding your gases. Okay, so we have studied that PV upon nRT is equals to 1, and for the ideal gas, and that's where this is called as your compressibility factor Z, and we know that Z is actually less than 1 for real gases, okay, at low temperature, so there is where you are getting the hint. Okay, so it is given, right, that you have to do at lower temperature. So this PV upon nRT, since it's a real gas, so it has to be lower than 1. Now in order to become lower than 1, what should be the sign of this thing? It has to be negative, right? So the sign of this particular thing has to be negative, and that's where the answer comes from. Now talking about the dependency or independency. So since we have PV upon nRT and is equals to 1 plus you have like you have BPP, okay, that's what you have. Anything whenever you add according to the dimensional analysis, two things can only be added or subtracted if they are dimensionally same, okay, if the dimensions are same. Now you know that if you put all these dimensions of pressure, volume, if you put the values or units of pressure, volume, put the values of R in the terms of pressure and volume, that is atm and liter, and put the value of temperature, everything if you put and solve, in that case we will get it as dimensionless, okay, the overall value is going to become dimensionless. That's why this is equals to 1. Now if you have to relate it with this, so this whole thing you can relate it with this, okay, so pressure and pressure can be cancelled out. Your BP is going to be equal to V upon nRT. I am not telling that these things are equal, the dimension of this is going to be equal to the dimension of this, okay, the dimension of this. So dimension of both the side has to be same. So what is the dimension of BP then? Dimension of BP is going to depend upon a dimension of volume. Also it is going to depend upon the dimension of temperature. So is it temperature dependent or not? So yes, it is going to depend upon the dimension, is going to depend upon the temperature as well. So yeah, that is a temperature dependent thing, okay. So that's how it is. But the negative part I guess is pretty simple and pretty easy to understand, right? You might have understood it that yeah, how we have compared it. So unless and until you know about these things, you won't be able to do this. Let's go and take the next one. Okay, here is a easy one. Okay, this is pretty simple. If you have done quantum mechanics, if you have done questions related to these type of problems like hydrogen atom problem, then you can do this question very easily. It says that in a spherical polar coordinate system, a point A at xyz in the Cartesian coordinate system can be described as r, theta and phi, where r, theta and phi have their usual meanings. Fine. Expression for the volume of an indefinitesimally small cube confined by dx, dy, dz in terms of a spherical coordinate system is given by. Now this question can be done like this, okay. You might have seen that we write down like psi star psi d tau, and d tau in the Cartesian system, d tau has a value of dx, dy and dz, okay. That's what we have, because in the Cartesian system it's like that. In the polar coordinate, your d tau has a value of r square sine theta dr, d theta and d phi. Now it's a long derivation how you can approach to this. I'm not going to do that, but I'm just telling you from where you can like do these types of questions, okay. So unless and until you know the derivation of your hydrogen atom problem, or somewhere if you have done this, or mathematically if you have studied somewhere, then only it will strike to you that yes, this is what we have as the answer. So r square sine theta dr, d theta, d phi is going to be the value of it, and that's where your option number D comes from, okay. So both these things are actually values of your d tau, that means very small volume unit which you take in the spherical coordinate and the Cartesian system. Derivation can also be done, but that is going to take a lot of time, and I guess you will get that in books, because you can check that out. Let's take the next one then. Okay, it's a good one. Okay, it says that the rotational energy of the diatomic molecule is given by E rotational, and that is equals to J plus 1 HBE, where E rotational is in joules. All right. If the rotational constant of H2 molecule is given by this, okay, yeah, over here 1.8324 E plus 12, it means 1.8324 multiplied by 10 to the power 12. Okay, that's what it means. It is given in hertz. The rotational period of H2 molecule in J is equals to 10 level is. Let's try to do this. So first of all, you are given with E rotational, and that is equals to J plus 1 and HBE. All right. This is what we have. We know the value of BE, we know the value of J, so we can put here. So the value of E rotational is going to be you have 10 and 10 plus 1, all right, and multiplied by H multiplied by BE. BE is 1.8324 into 10 to the power 12. Okay, that's what I have. What I can do is I can find out the energy, and energy can be related with your frequency. Since E is equals to h nu, so I can write down in the place of E rotational, I can write down E is equals to h nu. Okay, so in the place of E rotational, I'll write down h nu because that's what the energy is. And the other side, I will have 10 into 11 into h into 1.8324 multiplied by 10 to the power 12. Now this h and this h can be easily cancelled out. You need to, like, you have got your frequency here. So frequency will be in hertz because BE was having a unit of hertz. So frequency will be in hertz. Okay. So that is going to be 10 into 11 into 1.8324 into 10 to the power 12. I'll use my calculator to do this. So on calculating this particular part, so 10 multiplied by 11 multiplied by 1.8324, that's going to give me 201.564 into 10 to the power 12. Okay, that's what I will get. So that's frequency. What they're asking is the rotational period. That means they're asking the time period, and that's where the values are also given in seconds. You know, 1 upon hertz is second, so this frequency is in hertz. You need to find out the time period, so that's 1 upon frequency, and that is equals to 1 upon 201.564 into 10 to the power 12, and this whole thing is going to be 1 divided by 201.564. It's going to be equivalent to, okay, I'll write down here. So this time period is equivalent to 0.00496 into 10 to the power minus 12, because this will go upside to become minus 12. This will come out in seconds. You can put, like, and you can shift this point to this 3 units. That will become 4.96, or time period will become 5. So either you can write it down as 4.96 and multiplied by 10 to the power minus 15 seconds. That's where you will get your answer. Okay, so the answer will be 5 into 10 to the power minus 15 seconds. So this is how it was done. And like, see, this question was not difficult one. You can see the question was pretty simple, but what you have to look upon is they are not asking the energy, they are not asking the value of B, they are not asking the value of moment of inertia, which usually is asked in the exams. They are asking the rotational period. So you have to find out the frequency and then convert that frequency into time period. Okay, so this was the way to approach this question. Okay, let's take the next one. It says that for a harmonic oscillator in its ground state, that is when V is equals to 0, the energy is given by E is equals to half h nu, where nu is the vibrational frequency. This is due to, so the energy is equals to half h nu. That's what is given to you. You know that for the ground state or for the harmonic oscillator, the energy in the Vth state is given by V plus half h nu, right? This is the formula, and for the ground state V is equals to 0, so it becomes half h nu. So why it is equals to? So it seems like in the ground state the molecule is not going to vibrate, or it's not going to have any vibration, so it will only have potential energy. That's what comes in mind. Or it might come in mind that, okay, in the ground state, since we have frequency, so the molecule only has kinetic energy, it does not have potential energy, right? So anything can strike to your mind, and a person strikes either option A, or he will opt for option number B. Option C is correct because of the Varial theorem. Varial theorem says that the total energy of the system is sum of your kinetic energy and potential energy both. So the total energy cannot be just kinetic energy or just potential energy, it has to be sum of both of them, and that's from where your option number C becomes your correct option. Okay, so you have to be aware about these. This question, now it is from your CSIR net exam. Okay, it's a direct question from CSIR net exam. You have done this. This question can be done from like second thermodynamic equation of the state. Okay, second thermodynamic equation of a state, and you know the answer is 0, right? This you might have already done many times in your like during your CSIR net preparation. If you want, I can solve this. Okay, I'll just show you how, like, quickly how it will be done. So basically the derivation can be done from the second thermodynamic equation of a state, that is del H by del P at constant T. This is equals to minus T, and we have del V by del T at constant P and plus V. Now here you have to use your ideal gas equation to do that. Now for ideal gas equation, you have PV is equals to RT, or you can say V is equals to RT upon P. Okay, that's what I have. Now if I differentiate this V with respect to T, keeping P as constant, that means if I do dV upon dt at constant P, the value of that will be, see, P is a constant, R was already a constant, P is also constant according to this. So P can be taken outside. Differentiation of T with respect to T is just going to give you 1. So you are going to get R upon P here. So the value of this whole thing can be R upon P. So I can just put it here. So del H upon del P at constant T is going to give me minus TR upon P and plus V. Now you can put the value of V, right? V is equals to RT upon P. So you can put here, so it's minus TR upon P and plus RT upon P. Both these things are going to get cancelled out. We'll get 0 as the answer. This is how it will be done. The derivation is this, and logically also for ideal gas, the value which comes from the first thermodynamic equation of state or from the second thermodynamic equation of state, both the values are equal to 0. Okay, you should remember that. Okay, let's take the next one then. The next question says that the half-life of the decomposition of substance dissolved in chloroform is 6 hours at 298 Kelvin. How much of the substance will be left after a day if the initial weight of the dissolved substance is 160 milligram? Okay, so that's what is given to you. So T half is given to you as 6 hours. All right, now that's what it is. So a rate constant will be 0.693 upon 6. Let's keep it in hours only. Okay, so that will be like hours inverse. All right, now the next question, since it's a half-life, so we can assume that this question is this is a first order reaction. It's not given that which order reaction it is, but let's assume it as a first order reaction. It says that it's a decomposition of something, some substance in the chloroform. So that's a first order reaction kinetics. Okay, now they are asking that how much substance will be left after a day if the initial weight of the substance is 160 milligram. So put it here. So your K is equals to 2.303 divided by T, and then you have log initial concentration, let's say A divided by A naught divided by A, that is final concentration. So K is 0.693 upon 6, and this is 2.303 upon time will be a day, that means 24 hours. And then you have log initial concentration is given to you as 160 milligrams. Final concentration you have to calculate. Let's keep it as X. So just you have to solve it. Use your calculator to do that. So you have 0.693 multiplied by 24, and then you are going to divide this value by 6, and whatever it comes divided by 2.303. So your answer will come out 1.2036. Okay, that's what it will be, and it will be log 160 divided by X. So this is going to be anti-log. So 160 divided by X will be like anti-log of that. So anti-log of 1.203. So let's do this. So this whole value, if you find out the anti-log of it, so this whole thing is going to be so this is going to be 15.98. okay, that's what is 160 upon X. So X will be around your 160 divided by 15.98. divide this will come roughly around 10, you know, because this is something related like nearby 16 divided 160 divided by 16 will give you 10. So 10 is going to be the answer. So the question was about the half-life was given and the decomposition was happening in chloroform. Generally the reaction which happens in chloroform follows your it is going to follow the radical mechanism, and radical mechanisms are generally first order. Okay, so that's where I have taken the reaction to be a first order reaction, and that's how I got the answer. All right, so these things you should know, then only you will end up getting the correct answer. Okay, let's take the next question. It says which of the following belongs to the same symmetry group as NH3. Now you know that NH3 molecule has a pyramidal shape and it has a C3V point group. Okay, so in the same way you will have, if you look upon BF3, it's a planar molecule. Okay, the point group for BF3. Okay, let's draw the structure. So NH3 looks something like this. Okay, this is how NH3 looks. BF3 is going to look like a planar molecule. All these three bonds are going to be on the same plane. CH4 is a tetrahedral molecule, so the point group is tetrahedral. BF3 has a point group of D3H. Talking about CH3OH, this is going to have C3V. Basically, it is not going to have C3V because this molecule will be something like this. Okay, you can understand it because this oxygen and hydrogen bond is not going to be in the same line, so you won't be having access over here. Okay, so the only thing which is possible is a plane of symmetry, and that plane of symmetry makes it CS point group. All right, talking about the fourth one, this is going to have a C3V point group. That's because the carbon is there, hydrogen is there, all the three chlorine are actually in the same way how the ammonia hydrogens are there. Okay, and in the place of lone pair it is replaced by the hydrogen here. So yeah, this is having C3V point group, and that's what the answer is. So the molecule which belongs to the same symmetry group as NH3 is option. Okay, so this is how it has to be done. Let's take the next one. See, here again it says, among the following, which molecule will have a smallest spacing between the vibrational level? Spacing between the vibrational level, okay, that means the distance between the vibrational level. If you are taking a harmonic oscillator, that is equals to h nu, right? This is the spacing between two vibrational levels. Okay, between two vibrational levels. Now, once you know that, that means h is a constant, so everything depends upon frequency, and frequency, you know, it's equals to 1 upon 2 pi c under root k upon mu centimeter inverse, right? So that means frequency is inversely proportional to reduced mass. So higher the reduced mass is, smaller is going to be your frequency, and smaller the frequency, smaller is the spacing between the vibrational level. So they were asking the smallest spacing between the vibrational level, that is only possible in the molecule or in the option where the reduced mass is highest. Now the reduced mass is obviously going to be highest in the case of option number C, because both the masses are more here over here. For those who don't know, the formula of reduced mass is m1 m2 divided by m1 plus m2. All right, so this is what it is. Now if m1 and m2 both values increases, reduced mass increases, frequency decreases. If frequency decreases, spacing between the vibrational level also decreases. Okay, so this is how the things are related to each other. All right, let's take the next one then. The next question says that the face centered arrangement of, I think that's the last question which I'm going to take. Okay, we have finished very quickly, but yeah, I would highly recommend you to watch to see the question paper of TIFR 2020 and solve more questions. Okay, these will give you some hint that yeah, these types of questions are there. If you apply your mind, if you apply your logical analysis, you will be able to solve them, you know. So just try to do those questions which are left out. Okay, here it says that in a face centered arrangement of A and B atom, where A atom are at the corner of the unit cell, B atom are at the face centers. Each unit cell, one A atom is missing from the corner position and one B atom missing from the one of the face position. The simplest formula for the resulting compound is. So let's draw this. Let's draw this in a cube. Okay, so we have this cube. So here in this particular cube, I'll use different colors to explain this. So we have atoms at the corner. Okay, we have atoms at the corner. So let's say these are the atoms at the corner. Okay, and we have atoms on the face center. So let's take these green atoms at the face center. So we have face center here, 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 the top, on the back side, the front. Okay, what it says that fine, it says where A atoms are at the corner of the unit cell. So red ones are A atom and B are present on the face center. So green are B atoms. Okay, it says for each unit cell one A atom is missing. So atoms per unit cell, if I talk about it, so how many atoms do I have? If I talk about A, so how many A are there? So atom contribution I should write down. So contribution of atoms per unit cell. So for A, each atom is at the corner and each corner atom contributes 1/8. Since there are only 7, why? Because it said, right, that one of the atom is missing from its position. So there are just 7 of them which are present over there. So let's see. So yeah, only 7 of them are present. So into 7 will be done, right? In the same way, contribution per unit cell for B, since they are on the face center, and atom on each of the face center contributes half, and in a unit cell how many face center will be there? Obviously 5, because one of them is going to be missing from its place. Okay, so 5 will be there. So 1 upon 2 into 5, or you can say 5 by 2. So this became 7 by 8, this became 5 by 2. Now you have to find out the formula. So it became 8, A 7 by 8 and B 5 upon 2. In order to balance that, you have to multiply with, let's say multiply everything by 8. Okay, multiply the whole equation by 8. So it will become A 7 by 8 multiplied by 8 and B 5 by 2 multiplied by 8. This 8 and this 8 will cancel out. This will cancel out it 4 times and it will become A 7 and B 20. So that's how you got your answer as option number B. But it is very important to understand. Okay, once again I'm explaining. See, atoms A were at the corner. Each corner atom contributes 1 by 8. Since only 7 atoms are there in a particular unit cell, so that's why 7 into 1 by 8 will be contribution per atom per unit cell. And same for B, each atom is on the face center atom contributes 1 by 2. Since there are only 5 present, because 6 faces are there but 1 is missing as per the quotient, only 5 B atoms are there, so 5 into 1 upon 2 will give you 5 by 2. So 7 by 8 and 5 by 2, I have just written it, and since we have to make it in a simple whole number ratio, I have multiplied everything with 8, and that's how I got my answer. So we have taken 10 questions. There are total 40 questions. I just took 10 so that I can make the videos short and I can give you an understanding that how these questions are asked. If you see the organic questions, they are pretty simple. Okay, they are much simpler than physical chemistry question. So yeah, when I have solved it, it might feel that yeah, the questions are very simple, but in exam you have to, like, every time you have to think about a question and then you have to apply it accordingly. See, this question was also not direct. You have to like you have applied little bit of knowledge to do that. And again, if I talk about that question here, in this question they were asking about the time period, so you have to convert frequency into time period to get the answer. Same goes for this. Here you should know about the compressibility factor for the real gas at low temperature, and then only you can do it. So 2-3 concepts are involved in a particular question to do it. So try to look upon the question paper. It's not like it's impossible to do it. They are tricky, but the more you solve, the more you will understand, the more you will apply your brain to do them, and that's how you evolve as an aspirant, right? So this is it, guys. That's all from my side for this particular video. I hope you guys understood, you liked the video, you guys understood it well, and I hope that video was helpful to you. If you like the video, give it a like, subscribe to the channel if you have not subscribed to yet, and that's all. I'll see you in the next one. Till then, have a great day. Bye bye.